Cool. So in this video, we're going to go through what the difference between a deterministic model is with what a stochastic model is. Okay, deterministic and stochastic, right? And it all boils down to randomness. Okay, so deterministic, you can kind of think of this as determined, so fully determined, is one where there is no randomness. Okay, i.e., no uncertainty. Right? Stochastic, you can think of this as random, is where obviously there is randomness. Okay, i.e., there is uncertainty, right? You don't know what it is, or you're not 100% sure what it is. You can guess what it is. You can, have probabilities attached to it. You're 80% sure that this number is this, but you're never 100% sure, and that's what we want with deterministic, right? We want 100% certainty, right? So let's dive into a couple examples, right? So first example here would be E equals mc squared, right? This would be a deterministic model, right? Why? Because if you know what m is, if you know what c is, then obviously you know what c squared is, you will know with 100% certainty what e is, right? If you know what m is, if you know what c is, then you know what e is, right? 100% of the time, right? And this isn't, you're not guessing on what e is. You know if, say, m equals 5, if c equals 6, right? Then you know for sure what e will be, okay? That is what we call a deterministic model, right? You know everything. If you know all but one, you know everything, right? There's no guessing involved. There's none of that, right? Now, on the other hand, let me give you an example of a stochastic model. Stochastic means there is randomness, right? There is none of this 100% certainty, right? So, okay, let's take this example. Let's take fake e equals mc squared. Okay, let's go fake e equals mc squared. This is going to be our example, right? So let's say e, instead of e being equal to mc squared, it's now e equals mc squared plus, I don't know, z. Okay, so where z is normally distributed with mean 0 and standard deviation 1. Okay, so mean of 0, standard deviation 1. Okay, now the reason that this, right, the reason this is stochastic, right, is because we have the presence of this z, right? Because z is normally distributed with mean 0 and standard deviation 1, there is randomness, or rather there is, shall we say, inherent randomness. Okay, you will never know what z is, right? Z can be anything, right? As long as it follows a normal distribution, right? Z could be, I don't know, 0, it could be 0.1, it could be negative 0.57, it could be 0.38, whatever, right? You will never know. That's why we call it inherent randomness, right? It's not just random, it's inherent randomness. You will never know. You will never know what z is, right? No one knows what that is, right? It's random, right? Now, because of this fact here, right? I.e., you don't know what this is, right? Even if you know what m is, you can say m is still 5, c is still 6, right? Because you don't know what this is, how can you ever know what this is, right? With 100% certainty, right? That is not possible, right? As opposed to here, right? Let me change pen. Right here, you knew that with 100% certainty. If m is 5, c is 6, you know e, right? M is just 5 times 36, right? But in this example, even though m is 5 and c is 6, right? Because of this, right? E can be, I don't know, 162. It can be 108.38. It could be, I don't know, negative 97.2. I don't know, right? It's still possible, right? I haven't checked these numbers, obviously, but it's still possible that these numbers exist, right? As opposed to, say, back here, E can only ever be one thing. Sorry, E can only ever be one number, right? But here, E can be a wide range of numbers, right? Depending on what Z is, depending on this inherent randomness here. This, as a part of this, is what makes this random, and fundamentally, it's what makes this model, this fake E equals mc squared, stochastic, right? This is the randomness, the uncertainty part of this model, right? Again, E in this case, because of this Z, E can be basically anything. It can be any number. Theoretically, it could be any number, right? But the point is, right, you don't know what E is with 100% certainty. That is the main idea, and that is a main difference between a deterministic model and a stochastic model.